Hello, I'm Nikolay from the University of Oslo. We're managing Galaxy server there. So during the last conferences and meetings, there have been more and more scenarios where the Galaxy server will send jobs for execution to an HPC cluster. And in most of these cases, from what I've heard, the people who are managing the Galaxy server or Galaxy servers are either by mathematicians or computer scientists, but in their majority, they were not necessarily members of a high-performance computing group. So they had to fight their long and tough way through the walls of high-performance computing requirements and limitations. In our case, I come from a completely different setup. It's a mirror setup. I'm a member of a high-performance computing group, which set up a Galaxy server within the high-performance cluster environment. Some of my colleagues who don't like portals very much say that it's a side effect of the high-performance computing cluster. Whatever the case, this is what we have. And the scenario is the following. So every user at the University of Oslo, by user I mean student, professor, researcher, and all the collaborators who are attached to this user database, have automatic access to a computer cluster, to a high-performance computing cluster. And they have three ways to access this cluster. Of course, the old terminal mode, but this requires extensive knowledge of fastback scripting, some knowledge of queuing systems, and of course, if they decide to run their jobs interactively, for someone who is a newbie in the domain, it doesn't help very much. The second way to access the cluster is by web interface. This is a piece of a software platform which gains popularity. Maybe some of you have heard of the Open on Demand. It resembles very much the file manager of Windows type, which allows you to see the content of your cluster partitions and manage files there. Of course, it lacks a whole bunch of Galaxy's functionalities. And as one of my colleagues said, well, look, if we compare it, Open on Demand is a parasite and Galaxy is a high-end antibiotics. But for simple tools, if you want to run your jobs through a web interface, this is a solution. And of course, the third way to access the cluster is Galaxy. So far, we have cluster users and access to Galaxy. In addition to the account, every user receives this sort of a quota. Every user has between 500 gigabytes and 1 terabyte per person. And if this person declares a project, he may get or she may get up to 10 terabytes of space. And if they justify very well their needs, this storage can be extended. After these two slides, what do we have? We have Galaxy and storage, which we cannot access from within Galaxy. Because Galaxy out of the box does not allow you to see the high-performance cluster partitions. And we have to come with our modest customization here. Before I tell more about customization, we need to say 2 words about the setup. We have 2 prerequisites for this customization to work. The first one is that the storage partition shall be mounted to the Galaxy server. For us, this is not a big problem as long as we manage the server itself. We run it from a virtual machine. We mount the storage, in our case, by NFS, but it could very well be mounted by any parallel file system. We have tried it with BGFS. Before with GPFS, I don't know, maybe it will work for Lustre, but there is no reason for it not to work. And the second thing, the second very, very important requirement, that your Galaxy instance, our Galaxy instance, shall be running in a real user mode. I will take the opportunity here to thank Matthias Bernd, who is the person who developed this mode in Galaxy. It saves the lives of many people like me. And for those who are not familiar with the real user mode, I will just say that this is a mode where Galaxy runs the jobs on a cluster on behalf of the user who is logged into the Galaxy. In the previous days, we used to funnel all the jobs through a system user called Galaxy or another user, which would run the job for every user within Galaxy on the cluster. We'll get back the results and we'll display it on the Galaxy history panel. Now, we don't need this user any longer. The user who is logged into Galaxy runs the jobs on the cluster, as long as this is the same user. The user on the cluster and the user in Galaxy is the same. And the second slide, before I get to the examples, represents the challenges most of you know, especially those who played with the Galaxy code a little bit more. We know that the upload procedure can actually be decomposed in two stages. The stage of display, the display stage, where you see and you manipulate your files you want to upload, and the upload job itself, where the job ends up in your file. So the first stage is executed at the level of the Galaxy server. So it is executed by the Galaxy user, the user who runs the platform. Can you hear me now? Yes. And the second stage is executed on the cluster as a cluster job, and it is run by the user and process is owned by the logged user. And now we get to the example. So I will try to go through the scenario. As I said, we would like to give the user access both to their home directories and to the project directories when they keep the data. We reuse all the tools which exist from before, and we use this famous button, choose remote files. All the locations, they are listed in the file source files. There's nothing interesting here. So you have two additional here. Our cluster is called Fox, that's why I put the Fox name in front. So the two locations which we give the user access to are the home directory of the user and the projects. Let's start with the simpler scenario where the user will browse the home directory. It's very easy. The Galaxy logged user is the same whose home directory we want to browse. We just display the content of the home directory of the user. The second one is a little bit trickier because the user can be a member of many projects. So at this step, in the gray squares, I show the backend information, what you see in the console, so they can just match the information from the pop-up windows. So in this case, the user who is this case, me, I'm a member of these three groups. And these projects, CC 0, 1, 12, and 73, have the POSIX group name, respective member group for the three of them. As long as I'm a member of one of these groups, I will be able to see the content of these folders. So let's go into one of these folders, like EC73. As long as this is a group folder, it is highly probable that somebody else has put something into this folder. So in this case, there are folders which belong to me, like test Nikolay. There is a folder belonging to one of my colleagues, whose name is Trofim. So what if I select test here? The Galaxy system or our customization, it will know that I'm not allowed to browse the folders. I will get the error message. If I click on my folder, test Nikolay, I will see the content of the folder. So far, so good, but someone may say that this is a very improbable situation where somebody else has put their own files into my folder. But I don't know how many of you here manage HPC clusters, but sometimes when the users come to you and say, my disk is full, and when you start checking what files this user has in the directories, you usually find files from somebody else who has put files in his own directory. This is possible as long as they share the same group name. So in this case, if we have three files, the first two belong to me, but the third one, for some reason, was put here by my colleague. We don't have any means at this level, we are still at the display level of the upload. We don't have any means to block the upload of the file at this level. It has to be shown as long as the commands display the files within a folder we have access to. So if I try to upload the file which belongs to me, like Toto1, I will get a successful upload. But if I try to upload the file number 3, then it will be blocked at the next step. It is the execution of the cluster. All uploads are cluster jobs, and they are carried out by the user who is logged in the Galaxy. This is why all the jobs have to be run as a real user. As long as the Slurm job we are using, Slurm job tries to upload a file the job doesn't have access to, it will get stuck and we will have this error message. This is a little bit old version. In the new version, I played a little bit with the display so that there is actually permission denied under the window, but you have to scroll. Otherwise, it's quite scary to see that you cannot fetch So I just replaced the fetch with you are not allowed to, or permission denied to the file. So I think this actually covers the most of the scenarios you can have. As you can see, it is a very simple thing for people who we all browse Apple files. The problem is how from Galaxy we can browse the file on a shared file system, which contains the data of all the users in the cluster. And this is actually the small contribution we have. And for the last 50 days, we played with an S3 thing, so it's another storage place. We allow the users to create S3 buckets by sending a command to the cluster. They receive automatically keys and secrets, and they can start using them almost immediately. But this is unfortunately not a very good solution for Galaxy because we have to. Is it working? Yeah. Because it means that we have to modify the file where we define every S3 bucket every time a new user comes with their own buckets. So our decision was, I don't know whether this is a real solution, but it works and it hasn't been implemented yet. It could be a solution, no matter how stupid it may look like. The idea was to create a top level bucket for Galaxy with a key and a secret. And then, as long as the users have access through the terminal line to the same location, they can create their own subdirectories in this bucket. And the only thing they have to do is to respect the syntax of the name of the directory, which must necessarily contain their username. And then, if this works, we can simply filter the same way we filtered the files in the previous POSIX approach, so that if this is the content of the directory, this is the last slide, I'm sorry. If this is the content of the directory, the user will only see their own buckets simply because they contain their usernames. This hasn't been implemented yet. I just displayed here to see what to think about it. I know that it looks very simple. I know that the S3 buckets usually are used for sharing data which is common to everybody. But as long as we have a big cluster with many people working on it, one never knows. Maybe people would prefer to have their own buckets and keep their stuff there. Nothing prevents them to have common buckets for everybody. Like we can easily create it almost on the fly. So I think this was it. Sorry.
Any questions? Thanks, Nikolay.
Maybe I missed it, but if you want to display the home of the user at the display level, that means that the Galaxy user needs to be able to read them, right?
Yes. And the cloud, we can manipulate.
So that means that the Galaxy user needs to have a strong power on, have read access on all the home of every user, right?
Yes, the Galaxy user, it is the same user for the cluster and for the Galaxy. So all the commands which a Galaxy user issues is actually a command which is issued on the cluster.
Yeah, I was under the impression that if you use this real user mode, it's only when you run jobs, not when you display. Maybe I misunderstood.
No, it's about upload only. After that, of course, there is this big shortcoming, we were discussing it, that we create a copy of the file in Galaxy. I didn't find a solution for this yet, how I can avoid copying it, because uploading is copying it into the Galaxy storage space.
But I was thinking for the display. If you want to display what the user have on his own.
Oh, you can display it, yes. No, you cannot display it because this is a list of your Linux directory on the cluster. You have to put it into the Galaxy tree and then you can display it.
Okay.
Into the Galaxy history, sorry. It's a simple output of the list command, that's it.
Any other questions? Actually, I have one. You showed that at the project level, the user should have privileges to see the directories, but then at the test data that you showed in the middle, how can we actually display should be displayed, right?
This one?
Yeah.
Or this one?
Yeah, the test here
Yeah, the test, if you look at here,
shouldn't be displayed at all here.
no, because it belongs to a different group too. See here, look at the second line, it does not belong to the group EC 73.
Oh, no.
That's why, that's what blocks you.
Okay. Next. Yeah. Sorry.
Just a quick comment. So when you're creating user buckets, right? You have bring your own storage concept in Galaxy. So users can then, if the users already have their access keys and secret keys,
Mhm.
they can just plug that into the user file storage. That is either through repositories,
Mhm.
like in the user preferences through manage your repositories or manage your Galaxy storage. So you have two options.
Okay.
So any S3 bucket, anything, it could be AWS or it could be Minio, it could be any provider that is serving an S3 interface bucket, then it can be integrated. So your users can automatically just access their data
True
through
that.
that. Yeah. So then this simplifies your problem and you don't have to worry about, yet another creating some more complex things around that.
Thank you. I was not very knowledgeable how it works, so I
Yeah,
said,
can you
oh,
please have a look at the bring your
Yeah,
own
sure.
storage and bring your own data? Both the features that has been rolled out since the last releases, it's amazingly, it works amazing.
Mm.
You can also test it in usegalaxy.eu and probably in other Galaxy sites, but usegalaxy.eu already supports all these things.
Okay, thank you.
Okay, Sanjay. Okay, then let's thank Nikolay and